So this is section 1.8, solving chemical problems. Most of the chemistry problems that we end up solving in this course amount to being unit conversion problems, dealing with units. And so I'm going to teach you a technique called dimensional analysis. I first learned this as a junior in physics class in high school. And it's probably the most useful thing I learned in all of high school, was just how to manipulate units. It goes so many places with that. The dimensional analysis method, if you've learned other ways of converting units, it may be an adjustment at first, but it works so well for so many things like stoichiometry that I really want you to give it a shot learning how to do it with dimensional analysis instead of relying on equations or other methods. So what's really important is that units should always be included in your calculations. They multiply, divide, cancel, just like any other algebraic quantity. And so you can think of them as being like variables, the a, b, and the x and the y of algebra. But they're just centimeters or milliliters or different things like that. So in dimensional analysis, we make use of unit equations and conversion factors. So unit equations are things that are equal. So 2.54 centimeters is equal to 1 inch. And that's the sort of a thing that you'll look up in a table in your book, or it might be given to you in the problem. It says this is equal to that. This many centimeters is equal to 1 inch. So this is a unit of length, it's about that long. And the length is the same, we're just calling it a different name. We're using a different unit, and so the numbers are different, but it means exactly the same thing. So we can take any unit equation and make a conversion factor out of it. So 2.54 centimeters is equal to 1 inch. If we divide both sides by 1 inch, what does 1 inch over 1 inch equal? It equals 1. So that tells us that 2.54 centimeters per 1 inch is equal to 1. If we multiply something by 1, does it change the value? No, it does not change the quantity. So that is one unit factor that we can get from this unit equation. The other is the upside down. If we took both sides divided by 2.54 centimeters, we'd get 1 inch per 2.54 centimeters. That's another conversion factor. Either one of those could be used. How do you choose which one? You're going to look at the units. If you're starting with centimeters, then you're going to want to use this one, because when you multiply, the centimeters will cancel out. If you're starting with inches, you'll want to use this one. So we're going to use the one that the units we're converting from are on the bottom, and the units we're converting to are on the top. So any unit equation, put one side on top, one side on the bottom, you've got a unit conversion factor. So most conversion problems are going to take this form. You're given some piece of information, and there's another piece of information that you're seeking. And you need to apply conversion factors in between to get from one point to another. I don't think I have an example right here. I should. We'll make one up. So let's say that the paper is 11.5 inches long, and we want to know how many centimeters that is. So inches is the information given, and they're asking us how many centimeters. We need to apply a conversion factor. We want to get rid of inches, so inches go on the bottom, and we want to get 2 centimeters, so centimeters goes on the top. What's the relationship between inches and centimeters? 1 inch is 2.54 centimeters. So we look it up, and it's going to usually be shown in that form. So 2.54 is with the centimeters, and 1 is with the inch. The numerator is equal to the denominator. You can't say 1 centimeter per 2.54 inches, because 1 centimeter is about this big, and 2.54 inches is much bigger. That's not the same. You have to keep the number with its unit. And what happens here with the units is we've got inches divided by inches, they go away. And so then we've got 11.5 times 2.54. And my calculator is going to show me 29.21. But now that we've learned about significant figures, how should I report that answer? 29.2. This is one of those weird units, one of the weird conversions that's exact. So this 1 inch is exactly 2.54 centimeters. Our starting number had 3 sig figs, and so our ending number ends up with 3 sig figs. So I got rid of the 1. Any questions? Sometimes we have to convert units raised to a power, especially when we're dealing with areas or volumes. And to do that, you look at first the conversion or the relationship between the units without a power. So if we're looking for square inches to square centimeters, we start with centimeters and inches. And then we're going to square both of them. If you square both sides of the equation, it's still equal. You just have to be fair. It's like Tommy and Michael. You have to give, if I give this one cookie, I have to give this one another cookie the same size, right? It'd be fair. This has to stay equal. So we're squaring this side, we're squaring that side. Squaring this whole quantity means 2.54 squared, and the centimeters are squared. And 1 inch, the whole thing squared, is 1 squared inches squared. So if we carry out the squaring, 2.54 squared is 6.45, and square centimeters stays there. 1 squared is 1, and we have inches squared. And there we get our relationship between square centimeters and square inches. It's very important that the number gets squared. And we'll do some examples. Okay, so here's the first example. A word problem, of course. There are 2.60 times 10 to the 15 short tons of oxygen in the atmosphere. 1 short ton equals 2,000 pounds. How many metric tons of oxygen are present? And 1 metric ton equals 1,000 kilograms. Doesn't this look fun? Well, here in parentheses, that's a relationship that they're giving us. They're handing it to us. Here, look, you're going to need this. That's not the starting number, though, is it? And here's another relationship that's being handed to us. Those are conversion factors. We're going to need them, but that's not what we're starting with. We have to identify what's our starting number and unit, and what are they asking us to find. Well, the only other number in here is this guy, right? That many short tons. So that must be where we're starting. So 2.60 times 10 to the 15 short tons. And if you're not familiar with that unit, that's fine. I'm not familiar with it either. Short ton. Oh. So that's a short ton of oxygen. And what do they want us to find? Metric tons. So if you are word problem challenged, it's helpful to show more work than a person that gets this stuff naturally. There's two kinds of people. There's people who like word problems and people who hate word problems. And it has nothing to do with basic intelligence. It has to do with how your brain thinks. The people who hate word problems are probably better at creative writing and political science and being a good nurse because they care about people than the people who like story problems. But they might be the better engineers and mathematicians. It's just how your brain works. So I know that I've got some of you that are really good with word problems and some of you that hate them with a passion. So I'll be talking mostly to the people who don't like word problems, and the rest of you will just have to get over it. So short tons, that's what we're given, and I'm going to write way over here just to leave myself some space. I'm trying to end up with metric tons. The previous example I gave you was very basic. This one requires more than one conversion factor. This is not a stream that we can jump across in one leap. Okay, converting inches to centimeters, you can just hop across the stream with one conversion factor. So here we are on one bank of the river, and there's the other bank, and it's too far to jump. We need some stepping stones. There are multiple places that you could go. Some will lead you to a dead end, and some will lead you across. Now, because they gave us two conversion factors, that's a suggestion that we might want to think about using those. So we can start at the beginning and work towards the end. So here we've got this relationship. Short ton is equal to 2,000 pounds. That tells us we could leap from short tons to pounds because we have the relationship. So that's good. Do we know the relationship between pounds and metric tons? Just off the top of our head or in the problem? No. Like, okay. Well, you're going forward, you hit a roadblock, you're not sure where to go. Look at the other side and work backwards. So here, metric ton, here's this other relationship, metric ton and kilograms. If we knew how many kilograms, we could get to metric tons using this relationship. So if we had kilograms over here, we could get to metric tons. Now, can we go from pounds to kilograms? We may not know the number in our heads, but that's one we can probably look up pretty easily. Can somebody look that up, please?
1 kilogram is 2 pounds.
Okay, 1 kilogram is 2 pounds. I'll do you one better on that and say 2.2 pounds. We'll call that good enough. So this is our path. We made a plan. You need directions on how to get to your friend's house that you've never been to. And then if you actually want to get there, you have to follow the directions. So this is going to tell us what we have to do. These are going to become the units that are on top of all of our fractions. So I'm going to start over here, 2.60 times 10 to the 15 short tons. That's a long unit for a short name. So for each arrow tells me I need a conversion factor. So there's one arrow and another arrow and a third arrow. I'm going to take these units, short tons, pounds, kilograms, metric tons. I'm going to write them on the top. This always reminds me of watching Dora the Explorer. Anybody watch that? Maybe your younger sibling did. How do we get to the snowy mountains? Well, first we have to cross the bridge, and then we have to go through the dark forest, and then we get to the snowy mountains, right? And then they chant it. Bridge, forest, snowy mountains. Okay, this is our Dora path. Short tons, pounds, kilograms, metric tons. We figured out how we're going to go. It's dumb, isn't it?
I've seen it. It's really annoying.
I know.
Change it or lock it.
I've had multiple children go through Dora the Explorer stages, and so I just, yeah, really. Well, before that it was Barney, right? You guys were little when Barney came out. I know that. But James loved Barney. Oh. Anyway, you'll find that I have a lot of really dumb analogies. But the thing about dumb analogies is that you remember them. Okay? So, short tons, pounds, kilograms, metric tons. That's where we're going. So each arrow is a conversion factor. It's a line. Short tons, pounds, kilograms, metric tons. The hard part really is figuring out the map, the path in the first place. Once you get that, it's a piece of cake. It's following a pattern. So we've got our units out there. Now we're starting here with short tons. We want short tons to go away. We want to get rid of it. So we want to divide. So in this next fraction, we're going to divide by short tons. Because a short ton divided by a short ton is 1, and poof, goes away. You multiply something by 1, it doesn't change. Here, pounds. We want the pounds to go away. So we're going to divide by pounds in the next factor. Pounds cancel out. This is dimensional analysis. The units tell us what to do. Kilograms, we want to get rid of them, we divide. All the units cancel out. We do all the units first, then we go back and put in the numbers. So this first factor here, the relationship between pounds and short tons, that was given to us right here. 1 short ton equals 2,000 pounds. So 2,000 pounds goes on one side of the fraction line, 1 short ton goes on the other. The units have already told us where they want to be. Short ton is on the bottom, so we put the 1 with it. Pounds is on top, 2,000 pounds. The numerator has to be equal to the denominator. You can't exchange the numbers. Kilograms and pounds. How many kilograms? 1. I'm going to put a 1 in front of the kilograms. How many pounds? 2.2. Metric tons and kilograms. We were told 1 metric ton, 1,000 kilograms. So I put the 1 in front of the metric ton, and I put the 1,000 in front of the kilograms. You've got your equivalence statements. You figure out the path that connects them. You put the units in the path on the top. Then you put the units in the denominators so they all cancel out. You go back to your equation, your unit equations, and you fill in the numbers. Now we have it all set up for us. Start at the left, go to the right. Multiply by the top, divide by the bottom. So I've got 2.60 EE 15 times 2,000. If you want to divide by 1, you may. Times 1 divided by 2.2 times 1 if you want. Divide by 1,000 equals. My calculator is showing me a big old mess. Oh, I should write the mess down. 36. That's repeating. And the unit is metric tons. Anybody else get that number? Okay. We got an answer. Now we have to do sig figs. How many sig figs in this number? 3. How many in this one? Infinite. Short tons and pounds are both English units. So this is infinite. We don't have to think about that one. As we wrote it, how many does this one have? 2. A lot of conversion factors will say 1 of this equals something of that. What they're saying is exactly 1 is equal to about 2.2. So this 1 we don't have to think about, but the 2.2 is only 2 sig figs, so that's going to limit our answer. Here, metric tons and kilograms are both metric units, so that's infinite again. So because we didn't look this up very carefully, that's going to limit our answer. That's okay. So 2.4 times 10 to the 15. I'm tired of writing that, metric tons. Any questions? Okay, the area of a telescope lens is 7,903 square millimeters. What is the area in square feet? The unit, this is a simply worded problem, right? There aren't a lot of words, and there's only one number. So we're starting with square millimeters, right? And what do they want us to find? Square feet. Do you know how many millimeters are in a foot? I don't. So we're going to need something in between here. What do we know about feet? Inches. We know the relationship between inches and feet, so we can figure out inches squared and feet squared. How about millimeters and inches? So how about centimeters? Yeah. Centimeters to inches. Do you know the relationship between millimeters and centimeters? Well, there's different ways of thinking about it. That's one that we're going to fudge a little bit. There's 10 millimeters in a centimeter. Okay, so there we have our path. Millimeters squared to centimeters squared to inches squared to feet squared. I don't know why Dora's always going to the mountain, but she always is. And sometimes there's a grumpy old troll. Or the pirate piggies. You know what's worse? I would sing to you, but I can't. Aren't you lucky? What's worse than hearing that play in the living room is your child begging you to read the stories over and over again. Oh, I'm glad he's finally gotten past that. He wants Magic Treehouse now. Okay, so we need relationships here. We could do millimeters to centimeters in a couple of different ways. Let's go with this way. 10 millimeters is equal to 1 centimeter. You can actually get that off of a ruler by looking at the ruler. There's 10 divisions. Each division is a millimeter in the big centimeter. Relationship between centimeters and inches, 2.54 centimeters equals 1 inch. Relationship between inches and feet, I expect that you know that. To get the squared relationships, we just have to square them. Now, whether you square them before you put them into the big old equation or not is kind of up to you. So now we've got all the pieces, we just have to put together the puzzle. 7903 square millimeters. How many arrows do we have? 3. That means we're going to have 3 fractions. So millimeters squared to centimeters squared to inches squared. Oops. That's what happens when you're zoomed in. You can't see. Started in the wrong place. Sorry, I have too much dextromethorphan for my cough. Okay. We have the path. We take the units from the path. We put them in our equation. Then we start at the beginning, and we want to get rid of millimeters squared, so we put that in the bottom. So that goes down here. We're just going to go through and cancel out all those units except for the last one. Now, if you don't do this in the right order, because you skipped making a path, you're going to run into trouble. But if your path is reasonable, then you can just cancel these units out and they'll work out just fine. Now, because we're doing squared units, we need to be a little bit careful here. So 1 centimeter is equal to 10 millimeters. But that's 1 squared. Centimeter squared is equal to 10 squared millimeters squared. I have to square the number and the unit. In my equation here, I've got square centimeters and square millimeters. So I need to put these numbers in squared as well. What's 10 squared? It's 100. So 100. And what's 1 squared? 1. That's always nice. Here we've got 1 squared, inch squared equals 2.54 squared, centimeter squared. So 2.54 squared is 6.4516 and 1 inch. This centimeters to inches is an exact conversion. So when you square the 2.54, you really should not round it off. Then 12 inches and a foot. I forgot the 1 on the foot. 1 foot. 12 squared, inches squared, 1 squared, foot squared. And that's reminding me of Dr. Seuss. So 12 squared is 144. How many significant figures should this answer have? Same as you started with. Very good. Because this conversion, metric to metric, is exact. This weird one is exact. Centimeters to inch, English and metric, but it's exact. And this is within the English system. All these conversion factors are exact. So we started with 4, we should end with 4. 3.541. And the unit is square feet. Did I do that right? Sometimes we can ask ourselves, well, we should always ask ourselves, does this make sense? Is the answer reasonable? And sometimes it's easier to tell than others. On a straight conversion of units, what will happen is what I call the larger, smaller rule. Larger, smaller. So look at the units that you start with and that you end with. Which one's bigger? Square foot or square millimeter? Square foot is bigger. This one's larger. It should have this smaller number. The smaller unit should have the larger number. The most common mistake that students make is they'll get one of these things upside down, which sends it off in the wrong direction, either too big or too small. So the larger, smaller rule can help you identify whether your answer is reasonable or not. Any questions? I don't feel like doing part B. Okay, number 3. The speed of light in a vacuum is 2.998 times 10 to the 8th meters per second. What's the speed in kilometers per hour and miles per minute? Well, this is 2 problems. Let's do the first problem first. Now, this has a derived unit, meters per second. There's 2 units in there. And both of them are changing. We need to convert meters to kilometers. We need to convert seconds to hours. So this one is a little more challenging. So what we're starting with is meters per second. We're going to have a path on the top and a path on the bottom. I want to end up with kilometers per hour. Can I convert meters to kilometers? Yes. When you have metric units where one has a prefix and the other does not, meters to kilometers, liters to milliliters, anything like that, you can always do those in one step. If both of them have prefixes, you may have to do 2 steps. In fact, usually do. The centimeters to millimeters was kind of an exception. But we can do meters to kilometers. Do you know how many seconds are in an hour? What's an intermediate unit that we could use? Minutes. We could go seconds to minutes and minutes to hours. So what's the relationship between meters and kilometers? So a meter equals a meter, right? And I'm going to put the K in front of one of them. And what does K mean? 1,000 or 10 to the 3. So I've got the numerical meaning on one side and the prefix on the other side. There are other ways to do these, especially when you're going from like meters to millimeters or centimeters. But I'm going to show you in a very consistent way. So we've got the prefix on one side, we've got what it means on the other. So that's the relationship for this arrow. 1 minute is how many seconds? 60. Is that exact? Yeah. And an hour is how many minutes? 60. That's also exact. And this relationship is exact. So all of the conversion factors are exact. So we started with 4 sig figs. We're going to end up with that. .98. No. Times 10 to the 8th. Do these vertically. I'm going to start with the top. I usually go top to bottom, left to right. But if you wanted to start with the bottom, you could. I'm going to ignore the seconds for now. I'm just going to look at what I planned out for the meters. Meters to kilometers, 1 step, 1 fraction. Very short path, meters to kilometers. So down here, millimeters to kilometers. Then I'm going to take meters, this guy, And I'm going to put them in the denominator so he cancels out, like that. So I got the units set up for the top unit. Now I'm going to go look at the bottom unit. For the bottom unit, we had 2 arrows, seconds to minutes, minutes to hours. So that means I've got 2 more factors. Seconds is on the bottom. So these things have to be upside down. So seconds to minutes to hours is in the bottom of these fractions. And so over here it needs to be in the bottom. Here I've got seconds, I'm ignoring this now, to minutes, to hours. Because the second started out in the denominator. So my conversion factors for seconds are going to have the unit that's usually on the top, on the bottom instead. Now, I want to cancel seconds. I don't put it in the bottom here, because then I'd have seconds times seconds. I'm going to have to put it in the top. Everything's going to be upside down. So I'll put seconds up here. This seconds on the top cancels that one on the bottom. And now I need to get rid of minutes. Minutes is on the bottom. I'm going to put it on the top. And when I look at this, with all the units canceled out, what units are left? What's on top? Kilometers. And what's on the bottom? Hours. That's how I wanted it to work out. Now I go put the numbers in. Kilometer to meter. Well, I wrote it out here. I can also do these very easily, just on the spot. There's kilo on the top. I'm going to write what it means on the bottom. 1 kilometer is the same as 1,000 meters. Then in the middle here, 1 minute equals 60 seconds. 1 minute, 60 seconds. And over here, 60 minutes, 1 hour. 2.998 EE8 divided by 10 to the third. And when we write 10 to the third, sometimes it's not obvious what to do on your calculator. Think of that as 1 times 10 to the third, which is 1 EE3. I'm going to divide by that, times 60, times 60. And my calculator is giving me a mess. It says 107928 and 4 zeros. That's ugly, isn't it? On the TI-30XA, if you press the second function and the number 5 button that says SCI, it will put it into scientific notation for you. So that is 1.07928 times 10 to the 9. These are just my little scribblings down here. We already decided that we need to keep the same number of significant figures because each of these conversion factors was exact. So this one has 4, so this should have 4. 1, the 0, the 7, and the 9. We're dropping the 2. It's less than 5, and so we can just drop it off. And our answer is 1.079 times 10 to the 9. Any questions? You did calculations like this in your previous chemistry class. But I know the first time I took chemistry, I got an A. But I didn't really know how I got an A because I felt like I didn't understand anything I was doing. The second time I took chemistry, it made a lot more sense. So hopefully some of you will have that experience that it's like, oh, that's how that works. It really is a nice feeling when things start to make sense. We're going to do one more here. I'm not going to do the second part of that other one. I'm running out of time and I'm running out of voice. The average radius of a molecule of lysozyme is an enzyme in tears is 1,430 picometers. What is its radius in nanometers? So we're given picometers and we're asked to find nanometers. This is a metric prefix on meters. This is a metric prefix on meters. These are both lengths. We have two prefixes. The best thing to do if you have two prefixes is to do 2 steps. Go to the empty or the naked unit in the middle. From picometer, go to meter. And then from meter to nanometer. There are other ways you can do this, but I don't recommend them. If you have one prefix, it's 1 step. If there's 2 prefixes, it's 2 steps. So 1430 picometers, 2 arrows, picometers to meters to nanometers. Dora's path. Picometers, meters, nanometers. Picometers, meters, nanometers. Picometers come down here, so they cancel out. Meters come down here, so they cancel out. I didn't write anything down for the unit equations. We don't really have to for this guy. Here's picometer. What does pico mean? 10 to the what? 10 to the minus 12. So here is the prefix, the multiplier, and on the other side of the line I put what it means. Because this is like the given name, Thomas Kawagoa. Sounded all official at 8th grade graduation. And this is the abbreviation, Tommy Kawagoa. Sounds kind of childish. He'll want to change that one day, but for now he's still Tommy. So you put the meaning on one side, you put the prefix on the other side. So here we have the prefix on top, we have nano. Nano means 10 to the minus 9. So I'm going to put that on the bottom. Now when I put this into my calculator, I'm going to, in my head, think of this as 1 times 10 to the minus 12 and 1 times 10 to the minus 9. So the buttons I'm pushing, 1430 times 1 EE minus 12 divided by 1 EE minus 9 equals. And I come up with 1.430 nanometers. With something like pico, you're going to have to use scientific notation because your calculator doesn't have that many places. Something like milli, where it's 0.001, you could do it that way. But I think overall the factors of 10 work out much easier. Oh, I guess that wasn't real. That's okay. What's not the best? What did I do wrong in my answer? Pardon me? It's a significant figure problem. Because how many sig figs does this number have, really? 3. And I put the 0 in there, and I shouldn't have done that. Oops, that's not what to do. Yeah, so there's some other examples there. I'm not going to do them.